look at energy changes. We're going to look at those exo and endothermic reactions. Exothermic reactions, ones that give out heat, and I remember that by using phrases, oh dear, get the right button, such as exo, it's sort of like exit, gives out, and endo, well, that's like entrance. Heat given out, heat is going in. Now, to start this, we're going to have a look at one of these very simple things. This is a hand warmer, and what I'm going to do with this hand warmer is a very simple experiment. What I'm going to do is just take a thermometer, and this is a wireless digital thermometer, and I'm going to put it basically underneath one of these hand warmers. Now, I've got some software, and previously I've set the software up so that I've registered the thermometer, so it's got the thermometer in there, and what I'm going to do is I'm going to take a standard little template, and what we're going to do is going to record the temperature, and I'm going to record the time, and we're going to do the same on the graph here. I'm going to put temperature and time in there. So let's see what the temperature is. And so I can see the temperature here is 27.8, and we're not doing very much at the moment, so it's quite hot here for England. And what I'm going to do is I'm now going to take this metal bendy bit, I'm going to position it somewhere, and I'm going to click it. Now there it goes, and let's see if anything happens to the thermometer. I can see the thermometer changing, and I think the scale's a little bit large here, so we'll basically bring this down, and you can see that this reaction, just turning here from a liquid to a solid, it's all changed now, it's all gone, is giving out really quite a lot of heat, and this is now up to 42 centigrade, and it's still continuing its way up. Let's move this out of the way. So 46 centigrade, on its way to, so we've got to pass 44, we should hopefully make 46, and this is good to carry around in your pocket, a couple of those, one in each pocket, perhaps going to school, or if you're doing other things, and you can put that in your pocket, and you're keeping your hand nice and warm. This is a reaction using a chemical called sodium ethanoate. We have a supersaturated solution of this, and we basically dissolve as much of this salt as we can into hot water, and then we allow it to cool. Now, when you interfere with it, something basically happens, and that's what that metal disc did. It started making this stuff here crystallize, and they put some pink dye in there to make it look really cool, but it's just basically white crystals of sodium ethanoate. And so this is reaching about 48 centigrade, if you prefer 48 Celsius, and it is starting to level off. It went up quite sharply and then gradually it's cooling down, and that is also due to the fact that this is in the outside, so this is radiating heat out, and this is of course a potential problem we come to when we do some experiments, because we don't necessarily want to lose too much heat to the surroundings. So this is still going up at 48. It's staying more or less constant now. It's 48.1. It's sort of not doing very much. Now, once I've used this pack, and let's stop the experiment here. Once I've used this simple pack, then what I can do is, if I want to use this again, then all I need to do is put it in into some boiling water. This will dissolve the crystals, and then we gently allow it to cool, and then all I need to do when I want to activate it again is click the piece of metal in there, and it works. So it's available for me at any time. So that is an exothermic reaction. Are there any others? The other type, endothermic reactions. Yeah, there are various things to do some cooling down, and there is a particularly cool experiment that we're going to have a quick look at. So we're going to take the same trusty thermometer, and what we're going to do with this is we're going to try it in another experiment. So because this is a good experiment, then these are the sorts of things that are worth saving. So I'm just going to file, and I'm going to save my experiment as, and it's always worthwhile keeping all of these experiments that you do, and so we can save this as, this is sodium ethanoate, and basically this is a heating curve, and it's an example of exothermic. And recording all of those sort of things and keeping them are really quite useful things, because we can then easily refer to them. Right, part of my waffle there, and before I start this up on file a new experiment, is simply that one of the things I want to do is I want to basically do another experiment, and I need this to cool down. Right, so we're ready to have a go at trying to look at an experiment, this time with citric acid. So let's go over and have a look at this. Now I've got some citric acid. Hopefully the microphone followed me. It did, good. And I've got some citric acid I made up, and what I'm going to do is just a very, again, anecdotal experiment. And I've got here a polystyrene cup. This is much better for doing experiments than you might imagine, and I've got an old one here, and what I do is I tend to put my new cup into my old cup. That gives me extra insulation, because if I just put this thermometer in here, it tends to fall over. What I've done is I've put that in there, and what I'm going to do is I'm going to clamp my thermometer inside here, so now I can move it up and down. To make the heat loss better, what I've got is a piece of cardboard, and what I can do with this then is if I lower this over the top, then my piece of cardboard here is acting as a very primitive lid and will keep the solution from losing too much heat. So it's a slightly better experiment than we had last time. So let's take some citric acid. So this is 1 molar citric acid. This is not quite my favourite experiment, but it is quite a cool experiment, because we're going to take some acid and we're going to take some carbonate and we're going to have a look at those. So what I'm going to do is I'm going to start this experiment now simply by putting my thermometer in there. I'm ready with my sodium bicarbonate. This is in fact just bicarbonate of soda I bought from a shop, ready to do some baking. Right, let's have a look and see where we are with this experiment. So I'm going to do a new experiment, and we're going to record here the temperature. I will record the time and the temperature again. We're using Pasco software because it works really nicely, and let's have a look and see, if we start the experiment, how our temperature is. And our temperature of this solution is about 23.7 degrees. Now this is because this is just freshly made up, and it's going to be slightly colder, because when I make it up, in fact it got a little bit colder. So we've got that experiment going, and what I'm going to do is I'm going to add some sodium bicarbonate to this. Now to do this I am going to have to raise this little bit of cardboard up a little bit, because otherwise I'm not going to be able to get my chemical in. And what I'm going to do is I'm going to take a spatula full of this and I'm going to put it in, and let's see what happens. It fizzes, and what we should start to see is the temperature dropping. And what I'm going to do is I'm going to try and give you an idea of what's happening. And we drop down to 17.5, 17.4. So I've just changed the scale on here so we can see this reaction, and it's done a cooling curve. This has actually got a lot colder when I've added this carbonate, hydrogen carbonate, to this, and there's the experiment, it's over. In fact, if I were to do this experiment again, then it will also get colder again. It would jump down in the same way it's just done. So we're down at 17.2. I'm happy with that one, but just to show you, let's go over and put in another little spoonful. I'm going to raise the lid. Let's put in another spatula full in here. It immediately fizzes, and we'll see on this that it's again plummeting down. Had I put a larger amount, it would have worked probably just like this anyway. It would have jumped a lot further down, but we've taken this down now to probably around about 10 degrees centigrade, 10 degrees Celsius. We've dropped here down to 13. I'm hoping that it might just make 10. It should do, I'm hoping. Probably not. Now, I think I'm going to be lucky to get down to about 11 here. But again, the same curve as we are adding one substance to another, it's cooling down. And we'll just let this program terminate. We're down to 12 centigrade now, 12 Celsius, and I don't think it's going to get much lower than about 11.8. We're on 11.9. We can see this graph is leveling out. 11.8. I'll give it a few more moments to see whether it's going to reach 11.7. There, we've got to 11.7. And we can see this curve is now sort of basically straightening out down here. And then, of course, it's going to start warming up, because we're starting to bring in the temperature from the outside. So there we are, 11.6. It's getting there. It's thinking about it. And this is just the accuracy of this thermometer, that it really is hanging on there to 11.6. There we are. Experiment is virtually terminated here, so let's stop this recording. And again, a good experiment, so probably worth here saving this experiment and recording this one. And this one was citric acid plus sodium bicarbonate and this is an endothermic reaction. There are quite a few of these exothermic reactions and endothermic reactions we look at, and we look at some of them which are quite sort of useful, and we look at some of them that are more designed just for experiments to do, sort of for basic practicals that you could be examined on. But in fact, doing things like talking about the sodium ethanoate and its uses, this is still hot by the way, it stays hot for, as you probably know with hand warmers, for a considerable amount of time. Whereas the cold, well, that probably will get a bit warmer. Used in things like injury packs. This is quite an interesting experiment, the citric acid with the sodium hydrogen carbonate. Often we use ammonium compounds. And they probably work better than going and getting a packet of frozen peas out of the freezer. Let's have a look at a couple more experiments. So this one, not doing an awful lot now. The advantage of my 2 cups, I've got one experiment all done, and so I can put that aside and I can take out a fresh cup to do another experiment with. And all I will do is I will clean the thermometer. Now, other experiments that you might try. One of my more favourite experiments to do in the classroom, which involves eating, is either to try some glucose, and you can try this one at home. This is quite safe, and what we can do is, again, this is going to be a very anecdotal experiment. What I'm going to do is I'm going to take a small amount of glucose on a spoon and I'm going to eat it. What do I notice? Well, either with this stuff, glucose, or with sherbet, which is even better, they get cold in the mouth. You notice the temperature change. If I take this and I put it into some water, we can see a difference. Let's try this out very simply. So I'm going to get some water and put that in there. And what I'm going to do is I'm just going to get some water for this, so I'm going to pass the cup over and we'll get a little bit of cold water put in there. We don't want much. So we've got no more than about a quarter of this cup filled. And what I'm going to do is we're going to do the same setup. I'm going to record the temperature and then we're going to put in a couple of spoonfuls of glucose. I'm not expecting, however, as much change as we saw in the previous experiment, so this one won't be quite as exciting. So again, I'm going to set up the experiment, but we're not looking for as much temperature change as we saw before. So let's have a new experiment. I'm not going to upgrade my software just at this moment. We're going to select a measurement here: temperature, time and temperature. And let's record what the temperature is. And the temperature of the water here, 25.9 then. I'm not going to argue with the computer. 25.9. I'm not expecting here anything like as much of a change. So what I'm going to do is I'm going to bring this down here and let's pull it up. So I've got a much smaller range of temperatures to have a look at. I'm not expecting such a change, but let's try it anyway. Now really what I want to do is I want to stir this. And let's look at our temperature change. And you can see that it has dropped quite suddenly. and we've gone down from 26 Celsius to about 23.4, 23.3. It got down to, yeah, it's about 23.3 or 4. Yeah, it says about 23.4. It's gonna stay there, and it's now making its way back up. So we did drop quite rapidly, and then it's now going to start returning to its normal temperature. So let's stop recording, and again, file, we're going to save this experiment as, and this time it's glucose plus water. With an unusual spelling of water, and this is again endothermic. Another common experiment that we do is to have a look at the same sort of thing, but we're going to try looking at an exothermic reaction this time. Still don't want to upgrade it, and that's set up ready for me to have a look. So we're going to have a look at another experiment. I'll remove this out of the way, and this experiment is used sometimes in coffee cups, although it doesn't go actually into the coffee. What I've got is here some calcium oxide, some lumps of calcium oxide. I'm going to take this piece of cardboard off because it's going to be not that significant in this reaction, and I want to let you see what's going on. That was loaded. So what I want to do is I want to add some water to some calcium oxide. Here I've got some calcium oxide, and I'm going to take some of this and I'm going to put it at the bottom of my coffee cup. Now, what I might do is, if I was doing this as a real type of use experiment, what I might do is put in a much smaller beaker in here. And into this much smaller beaker I could put some coffee, and I could put some water, and I could stand that right inside this reaction. I'm not going to do that, but what I am going to do is have a look and see what happens if we add some water. So I've got some water. Now we're ready to go. What I'm just going to expect is the water is going to be at one temperature, and I'm going to do this the other way round, so it's not going to be as accurate, but we're only looking here for basic ideas. I'm looking for anecdotal evidence rather than at the moment doing a more formal chemical experiment. So what I want to record again is going to be the temperature. I'm going to record here time, time will go in there automatically. I'm going to record what's going on here, and let's change this. So there we are, we've got it at around about 25. Adding the water is not going to make an awful lot of difference. The water was coming out about 26, so we won't see an awful lot of difference due to the two different substances. When I get my second wireless thermometer, which I hoped was going to arrive a week or so ago, then we could do some tests of the water as well. But let's have a go and see what happens as we add the water. So I'm going to add some water to this. Just going to give it a little mix to try and make sure that it's all reasonably well mixed. I'm doing this in the old cup, and the reason I'm doing this in the old cup you might see later. And let's see what's happening here. Well, not a lot at the moment. We're not seeing a great change in anything happening, but this experiment sometimes takes a little while to get going. What we need with this experiment is just a little bit more patience as we try and do this to get it going nicely. So let's see, not a lot really at the moment. I can't see an awful lot. I put a little bit more in there just to sort of help it along a bit, but we are seeing a little bit of change. So let's change the scale here. Press the wrong button. Let's change the scale a bit more. No, press the right one. And we are seeing a slight change in this. 27.2, 27.3. It's going up very slightly, but I am hoping that it's going to start taking off in a minute. Going very slowly at the moment. I'm loath to change the graph too much because I know it's going to start accelerating. He says hopefully. I'm disappointed it's not going up as much as I would like it to. It does take a while. If you've seen some of my experiments on calcium oxide in the past, you'll see that they have worked much better. Perhaps this calcium oxide is looking a little sad. I will just put a bit more in, just in case I put too much water in. But I don't think I have. quite thick in there. I don't expect it to do much more than this. So yep, it's there. Looking a little bit disappointing. I was expecting that to rise in temperature a lot more and a lot quicker, whereas here it is going up, but it's only going up fairly slightly. Well, there's disappointment there from me, so I might try this one again as I normally do it. When I normally do this, I normally start with a boiling tube, and what I can do with this is I'm just going to make sure this is clean and dry. I'm not too worried, it's the same substance it's picking up. And let's put in a little bit. So I've put some in there, and since the other experiment really isn't doing an awful lot, what I'm going to do is terminate that experiment. Just going to stop it, and I'm going to do a new one. It really wasn't worth recording this one, so let's this time set this experiment going again. And what I'm going to do is I'm going to put my thermometer into this experiment. Now I haven't really quite got enough in there, so let's put a little bit more in. There we got our experiment, and we're ready to do it another time. So I'm going to move my cup out of the way, and we're going to clamp the test tube. Right, let's put some water in and see what happens with this. So we're recording, off we go. I can see the water making its way down through, and let's see what's happening with the temperature. I am seeing a temperature rise more than I expected. So we've already got up to 29.4. So this is looking better for my reaction. Again, it's leveling off, and great disappointment appears on my face, as this one I was hoping would get hot enough to do something. But let's have a look very carefully at what's going on. And let's look down here. Can you see the bubbles? Now, what might be causing those bubbles? Well, it could be just the water going through, or it could be that that water is getting hotter. And if I'm feeling this test tube here, it is getting a bit warmer. It's taking its time, and this reaction doesn't necessarily go immediately. And that'll upset it because I've just moved things around a little bit. So we'll see a change in the temperature. And that was something I really probably shouldn't have done, but it is now sort of still carrying on. So we've reached nearly 31 Celsius and it's still going up slowly. So I had hoped this was going to get a lot hotter than this, but things don't always seem to work out nicely for me when I do things live. And maybe my chemical's gone off a bit, so maybe we need to sort of get some new, or maybe I just need to sort of make sure it's okay. It's still going up slowly, but I don't think that is going to heat up my cup of coffee. Many times when we do this, we can reach temperatures of about 70-80 Celsius. This time I think it's going to take just too long. So we've looked at a couple of, four in fact, anecdotal type of experiments on exothermic and endothermic reactions, and we've looked at trying to do this in a plastic cup, a polystyrene cup, to try and keep the heat losses down, and I put a cardboard lid on top just to try and keep as much heat in as I can. Now what we're going to do next time is we'll have a look at this as a proper experiment, and by that we're going to have to measure the amounts that we're putting with each amount, and then we're going to have a look at a series of experiments and see what happens when we basically react one thing with another. So until next time, thank you for watching GCSE Chemistry Topic by Topic. If you liked it, give us a thumbs up and subscribe. My experiment, it's still going up slowly. It's just going to take probably the rest of the day to get up to where I want it to go. So until then, I'll see you next time. Take care and stay safe. Bye bye.